Good morning, students. Welcome to Bindu Dhadwal chemistry lesson. Today, we'll be solving some important questions from class 12th term 2 syllabus of chemistry. So, let us begin. Which of the following enzyme converts starch into maltose? Answer is diastase enzyme. Maximum covalency of nitrogen is, as the electronic configuration of nitrogen is 1s2, 2s2, 2p3. So there is 1s orbital and 3 p orbitals in the outermost shell. So maximum bonds that it can form are 4 bonds. So its covalency will be 4. Which is not regarded as transition metal. तो cadmium क्योंकि इसका फुली फिल्ड 3D सबशेल होता है, 4D सबशेल होता है, तो इसको हम ट्रांजिशन मेटल नहीं रिगार्ड कर सकते क्योंकि ट्रांजिशन मेटल्स होते हैं जिनमें D सबशेल पार्शियली फिल्ड होता है. इन विच 5F सबशेल इज फिल्ड, तो ट्रांजिशन एलिमेंट्स में D सबशेल्स फिल्ड होते हैं, लैंथेनाइड्स में 4F होता है, एक्टिनाइड्स में 5F फिल्ड होता है. तो एक्टिनाइड्स ऑप्शन बी करेक्ट आंसर है. विच मेटल हैज़ द हाइएस्ट डेंसिटी? सो ऑस्मियम हैज़ द हाइएस्ट डेंसिटी, अ डेंसिटी ऑफ 22.59 ग्राम पर सेंटीमीटर क्यूब. विलियमसन सिंथेसिस इज यूज्ड टू प्रिपेयर ईथर. इसमें हम एल्काइल हेलाइड को सोडियम एल्कोक्साइड के साथ रिएक्ट करते हैं और ईथर बनता है. विच इज़ द मोस्ट बेसिक? तो बेंजिल अमीन मोस्ट बेसिक होगा क्योंकि इसमें फिनाइल के साथ एक एल्काइल ग्रुप अटैच्ड है, तो ये एलिफेटिक कंपाउंड्स की तरह ही बेसिक हो रहा है. एनिलीन कम बेसिक होती है, एसेटामाइड भी कम बेसिक होता है. पैरानाइट्रो में इलेक्ट्रॉन विड्रॉइंग ग्रुप लगा है तो वो बेसिक नेचर को कम कर देगा. विच वाइटामिन इज सॉल्युबल इन वाटर? तो वाइटामिन बी एंड सी सॉल्युबल होते हैं, तो यहाँ ऑप्शन बी दिया हुआ है, ऑप्शन डी इज द करेक्ट आंसर. सो व्हाट इज एंटी फर्टिलिटी ड्रग्स? सो ड्रग्स विच आर गिवन फॉर टू अवॉइड प्रेगनेंसी फॉर कॉन्ट्रासेप्शन are called anti-fertility drugs. Anti-fertility drugs contain mixture of female hormones estrogen and progesterone, and example is Saheli. Name the vitamin whose deficiency is responsible for night blindness. So vitamin A, and for poor coagulation of blood, vitamin K. Haloarenes are insoluble in water but are soluble in benzene. Explain. This is because of poor dipole moment of haloarenes. So they will dissolve in so they will dissolve in non-polar solvents like benzene. Water is polar, so these will not dissolve in water. What happens when chloroform is exposed to air and sunlight? So it gets oxidized into a poisonous compound, carbonyl chloride, also known as phosgene. And similarly, carbon tetrachloride is hydrolyzed by steam at high temperature. So normally carbon tetrachloride is not hydrolyzed, but at high temperatures in presence of magnesium, it will get hydrolyzed to both the Cl will, this is unstable, 2 OH on the same carbon, so water is eliminated and COCl2 phosgene is formed along with water. Calculate the magnetic moment of Mn2 positive, atomic number 25. So electronic configuration with atomic number 25 is argon 18, 3d5 and 4s2, 18 plus 7, 25. But in plus 2 oxidation state, it loses the outer 2 electrons. So electronic configuration is reduced to Mn 3d5 and there are 5 unpaired electrons in the D or subshell because it has 5 orbitals, 1 electron each, so 5 unpaired electrons. Magnetic moment can be calculated by the formula magnetic moment is equal to under root n into n plus 2. N is number of unpaired electrons, which are 5 in this case. So 5 into 5 plus 2, that is 5 into 7, that is 35 under root, which comes out to be 5.9 Bohr magnetons. Define chelate with examples. Write the importance of chelates. So a chelating ligand is a polydentate ligand which on coordination with central metal forms ring compound. So such a ligand is chelating ligand. The process is called chelation and the compound is called chelate. Example, copper reacts with ethane 1,2-diamine on both sides to form bis ethane 1,2-diamine copper complex. Importance of chelates are they can be used to remove toxic substances which are mixed in blood by chelation. Using IUPAC norms, write the systematic names of the following. So the oxidation state in this compound for cobalt will be, because this is negatively charged, there are 3 such chloride ions, so the overall charge over here is +3. This is neutral, so oxidation state is +3. So name will be hexaamine cobalt 3 chloride. In this case, this is neutral, this is also neutral, so x minus 1 is equal to +1, x is equal to +2. So name will be diamine chlorido, then methylamine in bracket, and platinum chloride. Diamine chlorido, methylamine, platinum 2 chloride. Oxidation state is 2. Hexa aqua titanium 3 ion. Hexa aqua titanium 3 ion. This compound will be tetraamine chlorido nitrito N cobalt. Then 3 is the oxidation state, chloride. This is hexa aqua manganese 2 ion. This is tetrachlorido nickelate 2 ion. Now, because overall there is negative charge outside the compound, so ATE suffix is added to the metal. So these are the IUPAC names. Then tertiary butyl alcohol is much more soluble in water than normal butyl alcohol. Explain. This is because normal butyl alcohol has a bigger butyl group which masks the hydrophilic hydroxyl group and it is not able to form hydrogen bonds, so it's insoluble. But on the other hand, tertiary butyl molecule, because of more branching, tertiary butyl alcohol, this molecule because of more branching tends to acquire a spherical shape, so it's smaller in size, so it's not able to mask the properties of hydrophilic OH group, so it's more soluble. Describe the following. Gabriel Thalamide synthesis. So Gabriel Thalamide synthesis is a process in which thalamide is used to synthesize primary amines. This is thalamide. When it's react with alcoholic KOH, H is replaced with K, so we get potassium thalamide. This on reaction with alkyl halide will get converted to N-ethyl thalamide, which on acid hydrolysis breaks up into phthalic acid and primary amine ethyl amine. This is Gabriel Thalamide synthesis. Then next is coupling reaction. So coupling reaction can occur when benzene diazonium chloride reacts with ice-cooled solution of aniline or phenol. With aniline, it is going to form para-amino azobenzene, which is a dye in acidic medium, because this is basic in nature. Similarly, with phenol, it will react in ice cold conditions in alkaline medium to form para-hydroxyazobenzene. This is coupling reaction. Then explain what are biodegradable polymers. So polymers which can be decomposed by bacteria or microorganisms into harmless substances are called biodegradable polymers. Give chemical equation for preparation of one such biodegradable polymer. So let's polymerize glycolic acid. When it is polymerized, this group is repeated, CH2COO group is repeated n times, and this is biodegradable in nature. The product is polyglycolic acid. Explain the term addition polymerization with an example. So when compounds containing unsaturated double bonds are reacted under suitable conditions, one molecule adds into another to form a long chain of repeating monomers. For example, ethene when polymerized will form polyethene. Write all the isomeric aldehydes with the molecular formula C6H12O and give their IUPAC names and how many of them are optically active. So because there are 6 carbon atoms, of course the first one will be aldehydic group. So the remaining 5 carbons can be arranged in the following manner: either a straight single chain of 5 carbons or a chain of 4 carbons with methyl to the second carbon, because first is aldehydic group, or to the third carbon or to the fourth carbon. So the name will be, this is hexanyl 2-methylpentenyl, 5 carbons. This is 3-methylpentenyl and this is 4-methylpentenyl. Then we can have chain of 4 carbon atoms here. So 2 methyl groups are attached to second carbon. Then it is 2,2-dimethyl butanol. Then 2 methyl can also be attached to the third carbon. Then it is 3,3-dimethyl butanol. We can also have 2 methyls on second and third position. Then it is 2,3-dimethyl butanol. So on observing these products, we find that this product is an optical isomer because it contains a chiral carbon atom. That is, all 4 groups attached are different from each other. So this is a chiral molecule. Then this is a chiral molecule, methyl, ethyl, H and CH2CH2. This is a chiral carbon because this is not a chiral carbon, because 2 methyl groups are of the same kind. Then we have here also 2 methyl of the same kind, 2 methyl of the same kind, and in this is isopropyl H methyl. This is also chiral. So in all we have 1, 2 and 3 optical active isomers. Next is explain Wolff-Kishner reduction. So in Wolff-Kishner reduction, an aldehyde or ketone, when heated with hydrazine in the presence of a strong base, the carbonyl group gets converted to CH2 methylene group. So CH3, CH2, CH3. Propane is formed in this case. So an alkane is formed in Wolff-Kishner reduction reaction. That is all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.